All right, guys, so we're going to go on and start going through the review sheet, answering any questions. Now, if we don't get to one part or go over one that you want to see done, there's already a video on YouTube of the entire review sheet. I went through and did every single problem. It's already posted up there, so if you want to look at those, you can. And I did put it up there as Algebra 2 whole Chapter 3 review sheet. So it's the whole thing. But we'll go on and still go through some of these here together. So if we look at the first set, it's factoring, so we want to factor them. So 1 through 6 is one of those in particular that y'all want to look at. Which one? 6. So look at 6. So again, whenever we factor, the first thing we look for is a greatest common factor, something that will go into all three terms. Now, there's not a number that will go into all three, but there's still something we'll factor out. The negative, because we want the variable that's being squared to be positive. So we can factor the negative out of 3t squared, which gives us positive 3t squared. The positive 11t is going to become negative 11t, and the negative 6 is going to become plus 6. If there had been a number that was in common with all those, we would have pulled it out as well. Now we can do our 2 sets of parentheses with 3 spaces. Now we look for the sign. So the third term, if the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. Here it's positive, so the signs are the same and they match the sign of the middle term. So I'll have negative and negative. Our next step is to find the factors of the first and third term. So we'd have 3 and 1, t and t. I'm not going to be a big nitpick on variables, because if you had switched it and said 3x squared minus 11x plus 6, and then had 3x and x, that's fine. But if you do 3x and t, I'm going to count off. Because if you switch the variables, keep them all the same. Don't have t and x. Don't have 2 different variables. The only way that you can have that is if we started out with 2 variables, one on either end, then you'll need both. Just keep it uniform. Now the factors of 6 are 1 and 6, or which one would we use? We would put 2 and 3. And again, the last part is to check. 3t times negative 3 is negative 9t. Negative 2 times t is negative, which gives us negative 11t. Is that what we wanted? So this here is our answer. We do have to include whatever the greatest common factor, whatever we pulled out, in our answer whenever we are factoring. Any other questions on 1 through 6? If you do have questions later, again, that video is up there. Questions on 7, 8, 9, 10, or 11, or 12? Well, 7 is exactly like the one we just did. We'd have to pull the negative out first.
Would we do the same thing for 8 as we did on 6?
Yes. Now, when we look at this here, 4n squared minus 49, we have 2 terms being subtracted, yes? Are both of those perfect squares? Because what times itself is 4? 2 times 2 is? N times n is n squared. So 4n squared is a perfect square. 7 and 7. So a squared minus b squared is our a plus b times a minus b. This is just the formula for the difference of perfect squares. And in our case here, because we'll have plus and minus, our value of a is not 4n squared, it's 2n. So we'd have 2n and 2n. The value of b is what times itself is 49? Because if we have 2 perfect squares being subtracted, we're really looking at the perfect squares. So 7 and 7, 2n and 2n, we get this here. 10, what times itself is a squared? What times itself is 25b squared? 5 and 5. So we would have a and a, yes? 5 and 5, but we would also have b, because it's 25b squared, so we'd have 5b and 5b. plus and.
I have a question.
Mhm.
If there was ever a question out there like that, if the side was positive, would both of them just be positive?
We don't have the sum of perfect squares because the sum would not work out. Because for it to be positive, the signs would have to be the same, but we would get a middle term.
So then if we do 9, those...
Because 144 is 12, 169 is, so we'd have 14x factor out what?
Factor out, well, they're both equal to 2.
So we could factor 2 out of both, yes?
Basically, the ones with 2 with like 2 numbers that are like equal to
You can put them right there. So this one here had worked out to have a greatest common factor of 4 at the beginning. Because we had a common factor of 2 in both, we can pull them out. 2 times 2 is 4. If we had factored out the 4 at the beginning, we would have had 49x squared minus 36.
I feel like that's way more complicated than just
Great, actually doing the difference of perfect squares and then factoring both out. Yeah.
Wait, so on 7. Oh, wait. No. None of the numbers can go into each other.
So we would do it exactly as 6.
Oh, wait, no, I didn't.
So we can come back to it. I do want to make sure we get to every single, at least one of each type first. And if we don't have time, Quincy, if we don't have time, there is a YouTube video of me explaining all of them up there. You don't have to watch the whole video. You can jump to each part for the one that you want to look at.
I got it.
Okay. Now these two here, the only reason that these are up here is they're a little bit unique. So there is no greatest common factor. Because the third term is positive, the signs are the same and they match the sign of the middle term. Now the factors of a squared are a and a. Now in the other video, I do go through listing every single possible factor of 196. But the one we want is 14 and 14. And if we do check this, a times negative 14 is negative 14a. Negative 14 times a is negative 14a. Negative 28a, which is what we wanted, yes? Are these two parentheses the exact same thing? So I could rewrite this as a minus, oh, try that again. Okay. Pick which way you want to write it. So if you left it as a minus 14 times a minus 14, is that the exact same as a minus 14 squared? Pick which way you want to write it. Questions on these here. Now again, the method for factoring these two is no different than the first 6 we did. It just works out to have a special set of factors.
14 times 14 is what? 6.
Yes. Possibly, but again, it's easier just to go on and factor it. Because that gets a little thrown off, especially if a is not 1. All right, let's look at 17 through 23. This here, it says solve by any method. So any method that we've learned is good to solve for these here. So we could graph it, we could factor it, we could use the square root method, we can use completing the square, we can use the quadratic formula. We can use any method that we want because it says solve by any means.
So we could combine like terms.
For 17,
Yeah. And then,
well, x squared and 3x are not the same.
oh, no. No, not. So we
So if we wanted to complete the square, yes. Because if we wanted to factor, we could factor our two sets of parentheses and go from there. So if we wanted to, two sets of parentheses equals 0. Since 2 is positive, our signs are the same and they match the sign of the middle term, which is plus and plus. Factors of x squared are factors of 2, are 1 and we could check. And again, when we check with solving, do it off to the side somewhere, not underneath, because we still have to solve it. 2x times 2 is 2x. 1 times x is plus x, which is, that is our middle term, yes? When solving by factoring, if I have two things multiplied together to equal 0, one of them must be 0. There might be one on the test or one or two on the test that are already factored, two sets of parentheses equal 0, and we have to solve it by factoring. We just have to set those equal to 0 and solve, yes? So really at this point, we're just saying that x plus 1 is 0, x plus 2 is solve. Here we would subtract 1. Here we would so the answers are -1 and that's it. Yes. So x squared minus 9 equals 0. So this one here, we could factor it because x squared minus 9 is difference of perfect squares, yes? So it factored x plus 3 times x minus 3. We could use the square root method because there's no middle term. We could add 9 to both sides, take the square root, and solve that way. Or we can graph it, because as long as the equation is equal to 0, we can plug it in. X squared minus 9. Graph. Y equals x squared minus 9. And again, we're looking for where it crosses the x-axis. We're trying to see what value of x is going to make the y value be 0. Now, I'll clear all this out. We can go second graph to pull up the table. So again, we're trying to see where y is 0. And looking at this here, it's 0 at where? -3 and 3. Because again, we're trying to solve for where is y 0. So here, because we're trying to see what value of x will make the function equal 0. What value of x will make y be 0. So we can go up. So at 3 it is so we're trying to see when y is 0. And we could use the graph because we can see is graph. Yep, but we have to type it in y equals. X squared minus and that's it. Questions on this here? So if it's asked to graph, we can plug it into the graphing calculator and see where it's 0. If it does say to solve by graphing, it means that the solutions are going to be whole numbers. They're going to be nice answers, and we're going to solve it by graphing. Does that make sense? If it says solve by graphing, it's going to be whole numbers.
So then can we do 19 calculator too?
We can, but again, this needs to be 0. So we could subtract 2x from both sides. So we'd have 1/5 x squared minus 2x plus 6 is equal to so in the graphing calculator, we can hit y equals. We can clear out the other one. Now the fraction alpha y equals enter. We have 1/5 x squared minus 2x plus 6. So this is our function here, yes? And we can hit graph. Does it cross the x-axis? No. So it does not have real solutions. It still has solutions, they're just not real numbers. So most likely we expect I to be part of the solution. So that's what we have here. Because if it does cross the graph, we're going to have real solutions of some kind. If it doesn't cross it whole numbers, it means it's going to be irrational solutions.
Wait, is that what you got for your graph?
So if it doesn't cross, or it crosses at not nice numbers, we're going to have to use the quadratic formula or completing the square. Those are the only main two. Factoring only works if we do have nice numbers, either fractions or whole numbers. If it doesn't cross, we have to use completing the square or the quadratic formula. Here, why don't we go on and use the quadratic formula? Now that 1/5 is not nice, but what would happen if I multiply it by 5? So 5 times 1/5. It's 1, yes? Yeah. Because 5 times 1/5 would be 5 over 5, which is 1, yes? We didn't specifically talk about this, but with any of these problems, I can multiply this by 5 and still get the same equation, same type answers. Because 5 times 1/5 is 1, so I just have x squared. 5 times -2 is x, and 5 times 6 is plus almost 30. Okay, well, and 0. Now we do this so that we can get rid of that fraction. So if it had been 1/7, I would not multiply it by 5, I would multiply it by 7. We would multiply it by whatever was going to make those fractions or decimals go away. Now, if you wanted to try graphing it, you could. It's not going to get us anywhere. Because it's still going to end up being the same type equation. X squared minus 10x plus 30 still doesn't cross. But we can use the quadratic formula. So B in our case, so A, B, C is -10 because we take the sign in front of it. And we're going to plug it in for everywhere there's a B. So we'd have -10 plus or minus the square root of -10 squared. Minus 4 times A is 1. Since there's not a number specifically written in front of x squared, it is 1. And C is 30, all over 2 times 1. Now for the rest of this here, we're really simplifying. Once we get this typed in, plugged in, -10 is just 10. 2 times 1 is 2. The next thing I would do is plug everything inside the square root into the calculator. I wouldn't include the square root. I would just plug everything else in. So I can quit. So we would have parentheses, -10, -10 squared. I would put it in parentheses, minus 4 times 1 times -10. Hit enter. Make sure I type that in right, because I feel like nope. Because the last number is not -10. What is it? 30. Which gives us -20, yes? Now, if it had been 140, that's fine. But that means we don't have imaginary solutions. That means that graph should have crossed the x-axis, so we know something went wrong. Now, part of the reason I leave it in this form, because if I'd typed it in with the radical times, I would get a decimal. But if it's not an a plus bi form, it's going to tell us that it's non-real solutions. The 30xs will tell us that it's non-real solutions. So here we can come back over and write negative 20. So what do we know about the negative inside the radical? It's going to come out as I, which leaves us with the square root of, we could plug it into the 30xs to see what it is. Because if we plug that in, square root of 20 tells us that it's 2 square root of. So we have 2i squared of 5 is going to be our square root of negative 20. Now I want you to get to at least here. I want you to be able to get at least here. And I will give you all, pretty much every single point for this. I'll give you all the points for this. But can we reduce this? Are all three numbers, the 2 in the numerator and 1 to the denominator, all divisible by 2? So we can simplify this. 10 divided by 2 is? 2 divided by 2 is 1, so we just have I square root of. So this here is our solution. More likely, I'm being lenient on not simplifying. Any questions on how we did this here? Okay. Any other questions on these here? Questions on these here? 31? So we could try graphing this. I could move that back over and see if we get whole number answers, but we won't. But since we have a set of parentheses squared, we can solve this by using the square root method. So I would add 5 to both sides. Okay. So it doesn't cross the x-axis at 9 numbers, so we're going to have to move it the other way. The only other way is to multiply x plus 2 by itself and use the quadratic formula. Here it's going to be easier to add 5 to both sides. Now, we still need to get the set of parentheses squared by itself, so we're going to divide both sides by 2, which will tell us that x plus 2 squared is equal to 13 halves. And we leave it as this here because since it doesn't divide nicely, I'm going to leave it as 13 halves. Now we're going to square root both sides, because here the square root and square would cancel, telling us that we have x plus 2 is equal to plus or minus. Now in the yellow calculator, we can plug this in as the square root of 13 over the square root of 2, break it into 2 parts, and it will rationalize it for us, which will tell us that it's the square root of 26 over 2. And last but not least, we need 2. Subtract 2 from both sides, telling us x is equal to negative 2 plus or minus the square root of 26 over 2. Get the parentheses by themselves or x squared by itself and solve from there. So this here, so we could graph it that way. It's not going to work. It won't graph. But this here is already a perfect square trinomial. So if we wanted to, we could factor this. And again, this is all mainly dealing with completing the square. because the signs would be the same since the third term's positive. The signs are the same and match the sign of the middle term. Factors of y squared are y and y, and the factors of 144 are. So really it's saying that we have y minus 12 squared is equal to negative 100. At this point here we can square root both sides. Y minus 12 is equal to plus or minus. The negative is going to come out as, what do we have left over? Square root of 100 is 10i.
So the number when we have an I, the number goes in front of the I, correct?
Yes. And last but not least, we can and that's it. Now we could have applied the completing the square to this or the quadratic formula. I did do the full completing the square method with this in the other video where we moved the 144, found C, plugged it back in, and saw from there. It's a big loop because it works out that C is 144. So you essentially move the 144 over and add it back in. So you end up back where you start. But again, it's up there if you want to watch that. Now, 24 or 25, which one of these do we want to look at for completing the square? 24. Now again, if it gives, yes. Now, with the completing the square, since it tells us a method to use, I want you to use that method. If you get completely stumped on it and still can solve it another way, go on and solve it another way. You'll lose the 1 or 2 points for not solving by the correct method, but you'll still get the full points for getting it correct. Now again, for completing the square, exactly the first thing we need to do is to get a equal to 1. So for here, we'll divide everything by 2. Our next step is to get the constant term by itself. So we would add 12 to both sides and leave 2 spaces. So I have x squared minus 6x plus blank is equal to 12 plus blank. After we do this, we need to find the value of, which is b over 2 squared. And in this case, the value of b is almost negative 6. We have to take the sign with it. Negative 6 divided by 2 is, and negative 3 squared is 9. Once we find the value of c and plug it back in, we're going to factor and solve. Now x squared minus 6x plus 9 is going to factor to a set of parentheses squared, and the number that goes in with x is negative 3, whatever the number is that we had before we squared it to find c. On the other side, 12 plus 9 is 21. Our next step after this is to square root both sides. And over here, the square root and square would cancel, leaving us with x minus 3 is equal to plus or minus square root of 21. Again, I would check to make sure that that doesn't simplify. We could plug the square root of 21 into the yellow calculator and see what it tells us. And it's going to throw back out the square root of 21. So it means it doesn't simplify. But last but not least, we need to add 3 to both sides, telling us x is equal to 3 plus or minus the square root of 21. If the answer that we get on the other side of that plus or minus, that radical doesn't simplify completely, if it was the square root of 16, we get 4. We get a whole number, no I, no radical. You're going to need to add and subtract. If we get left with a radical like this one here, we're done. Because I can't add those two. If it had, like the last one, 10i, we can't add or subtract, so leave it there. Yes. Because second step is to get the constant term by itself. So again, we'll move on. If we have time to come back to this one, we will. If not, I do have it already in the video for y'all to watch. You can go back and watch it. I do not know. So 26 and 27. This again is the quadratic formula. We did one with the quadratic formula already. So feel pretty comfortable with this here. I do go over two examples with this here dealing with a being negative. So it would be good to go back and kind of see that and see how that works. But I want to make sure we get to everything else first. 28 through 30, find the value of the discriminant, describe the type of solutions, and find the value. So here, b squared minus 4ac. If it's greater than 0, we have two real solutions. If b squared minus 4ac is equal to 0, we have one real solution. And if b squared minus 4ac is less than 0, we have two complex solutions. Now, I'm not going to make you find the actual values of the quadratic equation, what it would have. I just want these parts here. I did include the actual solutions for 28, 29, and 30 in the back in the answer key, but I'm not going to ask for that on the test. Now, we can look at 28, and to find this and to do this, we need this equal to 0. We need it equal to 0. So for this here, we can subtract 4x squared from both sides, telling us 0 is equal to negative 4x squared plus 5x minus 10. b squared minus 4ac. So in this case here, what's the value of b? B is minus 4 times a. A is negative 4 and c is negative 10. Any questions on how we plugged in a, b, and c? Plug it into a calculator. 5 squared minus 4 times negative 4 times negative 10. Hit enter and we get negative 135. Yes? Yeah. So we just type it in. There's the value of the discriminant. That's 1/3 of the answer. Is it greater than 0, less than 0, or equal to 0? So we have 2. There's all three parts. Because I'm not putting, for grading wise, I'm not putting the two complex solutions as one answer. It's two parts because we have the two, because it's either going to be one or two, complex or real. Questions on any of this here? We feel comfortable at 28, 29, and 30? It's the exact same thing.
So could we do 20, 29? It's x on the other side. It's probably the same thing, but in my opinion, it's not the same.
So, b squared minus 4ac. So what's the value of b? Negative 1 minus 4 times a, which is negative 2 times c is negative 6. Type the whole thing in. Negative 1 squared minus 4 times negative 2, and I think it's times 6, yes? Make sure, nope. Negative 6. Negative 47. So this here is negative 47. Now, exactly, two complex. Since it's less than 0, there'll be two complex answers. If we had the other one, 49, we would have put two real answers, yes? You had only lost 2 out of the 3 points because the 2 is still true. it would be 2 complex instead of 2 real, because you'd have found 2 real. You did still get the 2 right. That's also why I put this as 2 parts. Questions on any of this here? Did that kind of answer this here? So you can just move it over and rearrange it. Now I did, again, cover that one on the other video. Here, find the value of C and factor it. Well, C is B over 2. Which one of these do we want to look at? $31. So for this here, what's the value of B? Negative 24. Now, if it doesn't divide evenly, you can leave it as that fraction. You don't have to turn it into a decimal. Now here, negative 24 divided by 2 is negative 12. Negative 12 squared is positive 144. So our quadratic is this here. And it'll factor to a set of parentheses squared. And the number inside the parentheses before we squared it was negative 12. That's why you can also use the review sheet on the test. Any other questions on 32 or 33? Because this is going to be 29 over 2 squared. Now, will 29 divide by 2 nicely? No. But we can plug it into the calculator. I would plug it into the yellow calculator, not the graphing calculator, because it's a little bit easier, a little bit faster to type it in. Yeah, because it's 29 over 2 squared, which is 841 over 4. So we're saying that it is x squared plus 29x plus 841 over 4. And the number inside the parentheses before we squared it was 29 over 2, and it's going to be positive. Yep, we're not solving, we're doing the main middle step. Any other questions on these here? Powers of I. Again, for these here, we're dividing the power by 4. If we get 0.25, it's I. 0.50 is negative 1. 0.75 is negative I. 0.00 is 1. But if it gives you 0.00, it's just going to give you a whole number, because it doesn't include 0.00 with after the decimal unless you specified around to 2 decimal places. We can pick any one of these, so 287. I'd grab the calculator, do 287, not times, divided by 4. I don't really care about the 71. I care about the decimal, which is 0.75. Yep, so any one of these here, we take the power, divide by 4, and we get one of these 4 answers. Any other questions on these here? So A, B, C, D, we want to evaluate these here, yes? We could go through, and we've done these already, where we combine like terms, add or subtract, going on, and so forth. Yes, don't change a thing. So if we looked at, say, B, 7i minus 27 plus 3i minus 2 is negative 21i plus, or negative 29 plus 10i. So you're talking about E. So 189 second I minus 361, and I think you did square, yes? If I wanted to, I could go back over and change it that way. The other way, plus 71 second I squared minus 38 second I. The other way we can do it is what I call the caret key. It's just an exponent key, 4. But anytime you use it, make sure to arrow out of the exponent because it stays up there. Otherwise, you might type everything else in there. But it simplifies it to 252 plus 189i. Any other questions on these addition or subtraction? Even with multiplication, any of these here, we could type them in exactly as we see them. So if we looked at h, 2 plus 3i, parentheses, 7 minus 4i, and 6 minus 2i, enter. We get this here, 182 plus 26i. And that would be our answer. Questions on any of the multiplication? No? Now division, if we remember back to doing this, to plug it into the calculator, we had to retype it as division. So for this one here, we would do parentheses, 8 minus 4i, close parentheses, divided by, open parentheses, 3 minus. Even if the denominator is just one term, you still need to put it in parentheses. Even if it's just 16i, you need 16i in parentheses. Same with the numerator. Even if it's just one term, put them in parentheses. Now we get this here. Now the next thing we can do is math, enter, enter. Math, enter, enter. We'll turn it from decimal to fraction. So we get 14/5 minus 2/5 I. And that's it. Questions on any of the fractions? We're good with those there? Okay, that leaves us with one last part. The bell's probably going to ring before I officially finish, but stay till the end. Because the last part, find the complex conjugate and their product. What's the complex conjugate of 4 minus 3i? Because we're just changing the sign in front of the term with I. Now their product is multiplying them together. And again, we can type that straight into the calculator, 4 minus 3i times 4 plus 3i, exactly as we have it. And it's going to give us a number. Whenever we multiply complex conjugates together, they will give us a number. The I terms will cancel out completely. But so, let me see. This here needs to be a minus instead of a negative. So guys, your test starts tomorrow. And again, if there's any part of it you're going back through it you need to see worked, the whole review sheet is up there. No.